My name is Terry, and in this video I'd like to do some examples of solving logarithmic equations. Before we start solving logarithmic equations, let's talk about some preliminary definition and properties of logarithms. So if you can look here on the screen, all right, your definition of logarithm, your mathematical definition of logarithm. A logarithm, y equals log base a of x, if and only if x equals a to the y. So this is your mathematical definition. It's a biconditional, okay? So biconditional means that, well, your y equals log base a of x. If y equals log base a of x, then x equals a to the y, okay? And then you can flip that around. If x equals a raised to the y power, then y equals log base a of x, okay? So logarithmic functions and exponential functions are inverses of each other. When we're solving logarithmic exponential function equations, we usually use exponential functions to undo logarithms. We use logarithmic functions to undo exponential functions. We use them with each other to solve. So now that is the mathematical definition of a logarithm. So in real layman's terms, real life, what really is a logarithm is just a fancy way to represent an exponent is all a logarithm is. It's a fancy way to represent an exponent, okay? So anytime you're solving an equation, you have variables in the exponent, we need to get them out to solve for them. We use logarithmic functions, we use logarithmic properties to undo that. All right, so logarithm is just an exponent. It's a fancy way to represent an exponent. So I have the graph of a logarithmic function here. The graph of a logarithmic function, so you can see that the domain of your logarithms, the domain for the x is just 0 to infinity, okay? You can only take the log of a positive number. You cannot take the log of a negative number. If you try to do that on your calculator, any technology, it'll give you some kind of a domain error, all right? So we can only take the logarithm of a positive number. That's going to be important when we're solving equations, because we're going to have to check our answers carefully to make sure the answers of your log equations are actually in the domain of the function. All right. There's some shorthands to write a couple of, so the base for logarithms can be any number, right? Any positive number. So it can be, 2, 3, 4, 5. There's some shorthands, okay? So if your logarithm is a base 10, if it's a base 10 when you're reading in your textbooks, logarithm base 10, they won't write the 10 there, okay? So I mean, if it's log base 2, you're gonna have a 2 there. If it's log base 3, they'll write a 3. Log base 5, they'll write a 5, okay? So, log base 11, whatever the base is, they'll write it there, okay? If it's base 10, then they might not write the number that the base in there for you. So if you ever see this expression right here, log x, and there's no base written, it's base 10, okay? Natural log, okay, ln x is your natural log. Your natural log is base e, okay? So these are equivalent expressions. On your calculators, you have an LOG button and you have an LN button. The LOG button on your calculators is your base 10, log base 10 button, while your LN button is your log base E. So, and then one more, another thing, we have properties of logarithms, which is going to help us when we set up our equations and solve our equations. All right, anytime you take the log of a product, we can take log of a product and pull it out to sum of logarithms, okay? And then vice versa, if you have two logarithmic expressions being added together, you can take the two logarithmic expressions added together, write it as one logarithm of a product, okay? So, and then next one down, if you have logarithm of a difference, if you have a logarithm, if you have two logarithms being subtracted from one another, you can take those two logarithms, write that as one logarithm of a difference. Okay, so these are properties of logarithms. These are all the preliminary, that we studied in a previous section before that, leads up to solving the equations, okay? And then a logarithm of an expression raised to a power, we can bring the power out front. These are equivalent forms and these are properties of logarithmic functions, okay? All of which, everything here, we're going to need to use inside of our solving our equations, okay? So let's go back just with the definition, all right? Let's make sure we have an idea with the definition and how the definition works, okay? So if we just took an exponential function, 7 squared, so 7 squared, 7 times 7 is 49. So 7 squared equals 49. Here's an exponential expression, the exponential equation. So 7 raised to the second power, 7 times 7 is 49. Let's say that we want to write this right here as a logarithm, because we can write all of our exponential equations as logarithmic equations. We go back and forth, okay? So we want to write this equation right here as a logarithmic equation. Well, here we go. What is a logarithm? A logarithm is an exponent. Logarithm is a fancy way to represent an exponent. So which number here is the exponent, okay? The 2 is the exponent. So 2, you set 2 equal to your logarithmic expression, because the logarithm is the exponent. Set the exponent equal to the log, the base is 7 of 49. So 2 different ways to write the same expression, okay? So this is exponential form, this is logarithmic form of the same thing. Okay, so how to go from exponential to logarithm and back. Just remember, a logarithm is an exponent. Here's the exponent, goes on that base. Okay, so that's how these are worked out. All right, 3 raised to what power is 27? All right, so 3 raised to what power is 27? This is a logarithmic equation, okay? So we're not going to solve it yet. Let's just go ahead and write this as a logarithm. This is an exponential equation, okay? So 3 raised to what power equals 27? Well, let's say we want to take this and write it as a logarithm. To write exponential as a logarithm, use the definition. The definition is a logarithm is an exponent. That is what this says here, okay? This here, mathematical jargon, says that the logarithm expression equals y, and y over here is the exponent. So logarithm is an exponent. Where's the exponent here? It's in the it's up here. X is the exponent, okay? It's the variable. So you set that exponent equal to the log expression, okay? Logarithm is the exponent. Set the exponent equal to the log expression, base is 3 of 27. Okay, so this is how we're going to write exponential functions as logarithms, and then when you backtrack and write it the other way, I would if you have the logarithmic expression. Just remember that the logarithm is the exponent. This here is the exponent, goes on that base, okay? So this means 3 raised to the x power is 27, okay? So this is just going through the definition. All right, so can we work logarithms? I mean, can we figure logarithms out in our head? Can we do logarithms without a calculator? Is it possible to evaluate logarithms without using technology? Okay, so I mean, if it comes out even, sure, we can figure out. If we wanted to figure out what is the log base 5 of 25, okay, can we do this without a calculator? Sure, we could. What is a logarithm again? Logarithm is an exponent, okay? So we want to know what is the exponent goes on this base 5 to give us 25. 5 raised to what power gives us 25? Well, 5 raised to the second power is 25, okay? So that right there is going to give you 2, okay? 5 to the second, so because a logarithm is the exponent that goes on this base, okay? Try another one. What is log base 2 of 8? Okay, so what is log base 2 of 8? All right, so log base 2 of 8. All right, so 2 raised to what power will give us 8? A logarithm is an exponent. What is the exponent goes on base 2 to give us 8? Okay, it would be 3. Okay, because 2 to the third power gives us 8. 2 times 2 times 2. So 2 to the third power gives us 8. Okay, try another one. What if we had log base 3? All right, so how about log base 3 of 1? Okay, so what about log base 3 of 1? Okay, what is the exponent that goes on this base to give us 1? All right, 3 raised to what power? Any number for that matter raised to what power gives us 1? 3 raised to the 0 power. Okay, talked about that in our last video we did with exponential functions. So 3 raised to the 0 power gives you 1. Okay, all right, maybe one more. Log base 7 of 7. Log base 7 of 7. Okay, can we do this? Yeah, sure we can. I mean, 7 raised to what power will give me 7 back? Okay, so 7 raised to what power gives me 7? 7 raised to the first power gives us 7, okay? So in terms of log, if it doesn't come out even, you might need to use technology, but otherwise, it's logarithm is an exponent. Just figure out what the exponent goes on that base. We're going to take logarithmic functions and exponential functions, write them interchangeable back and forth. You can write one as the other and so on, all right? So, so why is it important to understand logarithms? There's just so many applications, okay? We are going to focus on solving some equations, but there are so many applications of this, which will come up in a later video, but just to give you a little preview, okay? Amount of money in the bank is principal e to the rate times time. This is an interest formula that computes how much money you will accumulate after you put some money away in the bank, okay? Compounded continuously, that's where the exponential, so compounded continuously, and then R for the rate times time. So, sometimes, you're solving equations like this. I'm just gonna use this as an example. So maybe you wanna figure out, let's see, how much money will we have in the bank if we take maybe $500 and put it away, okay? Compounded continuously, and let's say we're gonna use a 4% rate of return times 3 years, okay? Something like this to solve, you can just put this in your calculator. You're gonna put some money away for 3 years, you're gonna earn 4% compounded continuously. When you come back 3 years later, plug it in your calculator, how much money are you gonna have? You can just type it in and plug it in your calculator and compute it, okay? However, what if instead of this kind of a question, okay, so instead of this kind of a question, what if you wanted to figure out, okay, let's say that you want to put $200 away, okay, compounded continuously at 4%, all right, but you want to know how long will it take. We're going to find time. How long will it take for my $200 to become $1,500? What if you want to solve for the time? You want to, instead of figuring out the amount of money, so you can just put this in your calculator. What if you wanted to figure out how long it's going to take? Okay, you want to figure out how long it's going to take for your $200 to turn into $1,500. Well, now we have to get that variable out of the exponent so we can solve for it, and that's where logarithms come in. So you can use a logarithmic button on your calculator to solve for that. But this is where logarithms come in. Sometimes the variables you're solving for are in the exponent, and to get the variables out of the exponent so we can solve for them, that's where logarithmic functions come in. So there's a lot of application. This is it. I'm just using money in the bank right now, but anything anytime you're dealing with any type of exponential growth, exponential decay questions, population growth, okay, so whether it's population of people, animals, bacteria, viruses, anything, any kind of growth like that, you can use logarithmic functions to figure out the time, the rate, because those are the variables in the exponent to help you compute that. All right. Okay, so let's look at some equations. Okay, so let's look at some of the equations that we want to learn how to solve. Okay, so we're going to start with the example number 1. So we're going to take log base 3 of 3x minus 1 equals 2. All right, so we're going to take log base 3. Okay, so log base 3 of 3x minus 1 equals 2. We want to solve this logarithmic equation. Okay, so it's a logarithmic equation. All right, we want to solve it. So how do we solve logarithmic equations of this form? We'll change them to exponential. Okay, so we go back and forth. Okay, the variable we want to solve for is inside a logarithm, so we want to get the variable out of the logarithm. How do we do that? We're going to change it to exponential functions. Okay, that's all right, because that's what a logarithm is. A logarithm is representing an exponent. Okay, and how do we do that? Well, we're going to take the logarithmic function and we're going to change it to exponential. A logarithm is an exponent. Okay, so here's the exponent. 2 is the exponent, goes on this base 3. Okay, so we're going to take 3 raised to the second power. Logarithm is an exponent. This is the exponent, goes on that base, equals 3x minus 1. Okay, so this is, so you want to change to exponential. All right, because that's what a logarithmic function, logarithms are exponents, okay? So here's the exponent, goes on that base, all right? And then we're gonna solve for x. Let's take 3 raised to the second power. So 3 raised to the second power is 9, okay? Equals 3x minus 1, all right? We wanna solve for x, so let's go ahead and isolate the x. We're gonna add 1 to both sides, okay? So left side, 9 plus 1 is 10, okay? On the right-hand side, the 1's cancel, so we have 3x, okay? So we're looking for x, okay? We wanted 3 times x, but we want x, so let's go ahead and divide the 3 out from both sides, okay? So move the 3 out of the way, so there's your x on the right-hand side, and the left-hand side is, looks like it's 10/3, okay? So here's the answer, all right? Logarithmic functions, you should take the answer, plug it back in, and check and make sure that you're not taking the log of a negative number. When you take 10/3 and plug it in, 10/3 times 3, 3's cancel, you get 10. 10 minus 1 is 9, okay? Log base 3 of 9, yep, 3 squared gives you 9, so log base 3 of 9 is 2, and so that works out, okay? So 10/3 for the answer, and so we are going to take logarithmic equations, change them over to exponentials so we can solve for the variable, all right? So here is example number 1, all right? I'm going to erase example number 1, put example number 2 up because it's going to utilize some of the properties we have on the bottom of the screen over there, all right? So here's example 1, let me erase this. So example number 2, like I said, example number 2 is going to utilize some of the properties, okay? So example number 2, let's take log x. So we're going to take log x, and we're going to add to that log of x plus 15. Okay, so we're going to add to that log quantity x plus 15. We're going to set that equal to 2. So here's example number 2. All right, we want to solve for x. X is inside a logarithm. So how are we going to solve for x? It's inside a logarithm. Okay. Well, we want to use the definition. We're going to take the logarithm, write the logarithm in exponential form, all right? But if you look at the definition, in order to change logarithm to an exponential form, you got to have 1 logarithmic expression, all right? We don't have 1, we have 2 logarithmic expressions. So we're going to need to take the 2 logarithmic expressions, change them to 1 logarithmic expression using our properties, and then apply the definition. Okay, so our 2 logarithmic expressions are being added, okay, so they're being added. So when you have 2 logarithmic expressions being added, all right, we're going to write them as a single logarithm of a product, okay? So you're going to take the 2 logarithms, write it as 1 logarithm, and take the quantities and multiply them, all right? So we have 2 logarithmic expressions. We want to write it as 1, so you're going to take log, okay? And then we're going to take these quantities right here, the x and the x plus 15, all right, x plus 15, and we're going to multiply the quantities, okay? So you got the 2 logarithms being added. So you're going to take the 2 logarithms being added, we're going to write them as 1 logarithm of a product, okay? Bring them to 1 logarithm, we're going to multiply the expressions, okay? Now we have 1 logarithmic expression, so now let's go ahead and we're going to use the definition, okay? And what is the definition? A logarithm is an exponent. So this is the exponent 2 that goes on, what's the base? Okay, it's not written here, so when the base is not written, when it's not written, base 10, okay? So this is base 10, so you're gonna put a 10 here, okay? Just that you don't have to write it there, but it might be easier to see what to do, okay? All right, back to the definition. A logarithm is an exponent. It's a fancy way to represent an exponent. This is the exponent, goes on this base, okay? So you have 10 raised to the second power equals, and on the right side we have the x plus 15, okay? All right, and again, just to remind you, logarithm is an exponent, so the 2, this is the exponent, goes on that base, okay? Set it equal to this quantity. All right, let's simplify the left and the right hand side. So 10 squared is 100, 10 times 10. The right hand side, let's distribute the x. So you have x squared plus 15x. Okay, Okay, so you distribute. This is a quadratic equation now, so we want to solve a quadratic equation. We want to move all terms to one side and have a 0 on the other side, so let's subtract the 100 from both sides. So we have 0 equals x squared plus 15x minus 100. Okay, so we're here. All right. All right, and then what do we want to do? Well, let's go ahead and we want to factor. Let's factor, okay? So when we factor this quadratic, let's see, x times x is x squared, okay? 15, so 15, we want two numbers that add up to positive 15, but the product has to be a negative 100. So let's maybe try positive 20, okay? So 20 times maybe a negative 5, all right? So 20. So you have x squared here, okay? And then you have 20 x's, take away 5 x's, that's 15 x's, and 20 times negative 5 is negative 100, okay? All right, and then to get your solutions to the quadratic, you're going to take each of the factors, set it equal to 0 and solve. So we have a negative 20 here. Take each of the factors, set it equal to 0, solve, and we have a positive 5 here, okay? Looks like we have two answers, okay? So it looks like we have two answers, but we gotta check our answers, right? So we gotta remember that, gotta be careful with logarithmic functions, okay? Logarithmic functions, domain is only positive numbers. You cannot take the logarithm of a negative number, okay? So let's go ahead and take negative 20 and plug it back into the original equation. Take negative 20, plug it in. Can we take log negative 20? You can't take the log of a negative number, so we actually have to not include negative 20 as one of our answers, okay? Let's check, make sure 5 works. When you take 5 and plug it in, log 5, we're okay, because it's log of a positive number. And over here, log 5 plus 15 is 20, log 20, that works, okay? So the only solution, the answer to number 2, x equals 5, okay? Only x equals 5. Make sure that you disregard, throw out the negative 20. And the negative 20 is not the solution because negative 20 is not in the domain of our original equation. It's not, doesn't even fall in the domain. So we cannot include this as an answer. All right? Okay, so let's do one more example. One last example. We'll do 3 total examples. Okay, so here's 2 of the 3. All right, so let's do one more example. So the next example, again, we're going to have 2 logarithms in our next example, but they're going to be subtracted, okay? We want to solve the log equation, but the next example is going to have the 2 logarithms being subtracted from one another. All right, so this will be our last example that we work through here. All right, so here's example 3. So example 3, we're going to take log of 3x. And we're going to subtract from that log of x minus 3. And we're going to set this equal to 1, okay? And so this is what we want to solve, okay? So how do we solve this, okay? Well, again, a logarithm is an exponent, okay? But you're going to use the definition. A logarithm is an exponent, okay? So this is the exponent, but goes on the base. But we have 2 logarithms over here. Okay, so we cannot use the definition logarithm is an exponent. We can't use that until we take our 2 logarithms, write it as 1 logarithm. Okay, we need to use our properties of logarithms. The property we need to use here is the subtraction. We have 2 logarithms being subtracted, so we're going to write this as 1 logarithm of a quotient. Okay, so we're going to take log. We're going to write our 2 logarithms as 1 logarithm. We're going to bring these quantities together as quotient. This will be the numerator. This will be the denominator. So you have a difference of logarithms, 2 logarithms. When you have a difference of logarithms, we can write the 2 logarithms as 1 logarithm of a quotient. So we take this right as 1 logarithm. Once you have 1 logarithm, now we can use the definition to write the logarithm in exponential form so we can solve. And how do we do that again? The definition, logarithm is an exponent. This is the exponent, 1, that goes on, base isn't written here again. So what do we do when the base is not written in for us? It's base 10. You don't have to write it down, but it just might be easier to see. So base 10. So a logarithm is an exponent. This is the exponent, goes on that base. We have 10 to the first power, all right, equals, and then you have a 3x quantity over x minus 3. Logarithm is an exponent. Here's the exponent, goes on that base. All right, and then solve, okay? So I can set this up as a proportion, okay? The left-hand side, maybe take this and put 10 over 1. The right-hand side, 3x over x minus 3. Right, and then we can cross multiply. Right, so multiply the left-hand side. Multiply the left-hand side, you'll have 10 times the quantity x minus 3. Multiply the right-hand, cross multiply. 1 times 3x is 3x. So anytime you have a true proportion, cross products are equal, property of proportions. And you can solve for x this way now. So distribute the 10, so you have 10 times x, and then distribute to 10 minus 10 times 3 is 30. Right-hand side, you have 3 times x. So I'm running out of space here, so let me travel a little bit, just because I'm right way down at the bottom of the board. I'll copy this step again. So again, we have 10x minus 30 on the left. We have 3x on the right. I just copied that step so you can see. We want to solve for x. So subtract 10x from both sides. Subtract 10x from both sides. 10x is canceled. So negative 30 equals 3x. You're taking 10x's away, so negative 7x. We don't want negative 7x, we just want to solve for x, so divide both sides by negative 7. All right, so the negative 7's cancel, so x is going to be 30 over 7. 30 over 7. And just as in the other examples, you should take your answer 30 over 7, substitute it back into the original equation to be sure that we're not taking the logarithm of a negative number. Got to make sure that you can have a negative number to represent x, but you just, when you plug it back in, you can't take the log of a negative. Negative numbers are not in the domain. You can only take the log of a positive number. All right, 0 to infinity is the domain of your logarithmic functions. Take 30 over 7, plug it in. So when you take 30 over 7 times 3, that's 90 over 7. Log of 90 over 7 is fine, it's positive. 30 over 7 minus 3. So 30 over 7, so this is, 7 goes into 30. 4 and 2 sevenths times. So 4 and 2 sevenths take away 3. You have 1 and 2 sevenths, which is positive numbers. So you can take the log. So 30 over 7 works. And that's your answer here. All right. Okay, so I hope this helps with making you feel a little bit more comfortable with logarithmic equations, with a little bit of overview from definition and so on. So this concludes this video. So I hope it helps. Thank you for watching, and stay safe and healthy out there.